Thank you for having us here. I'm Andrea Saylor-Seepkes, and I am high school math teacher, and I'm also lucky enough to teach high school robotics. This is the second year we've had robotics at USD 350, and we've definitely learned a lot in the past 2 years. I've got most of my class here tonight, and we're going to do a relatively short presentation because we're hoping that most of the time we have with you tonight can be question and answer, a little more informal. So I have Ethan Houston, Chase Mansell, Connor Hansen, Holt Ward, Jeff Lyon, and Liam Lannerman here. Kirkland Hudson and Connor Engel are also part of our class, and they were unable to be here this evening. So I'm going to turn it over to Ethan, and these guys talk a little bit.
All right, first of all, I'd like to thank you guys for coming tonight and allowing us to present to you. We're going to be covering 6 main topics tonight: engineering, coding, problem solving, competition, teamwork and social skills, as well as state and world qualifying opportunities. So with engineering, at the beginning of each year, Seepkes has us build a basic bot. So it is a claw bot for us to learn how to not only drive, but to code, as well as learn how to play the game. And after we've kind of learned what to do with the robot, then we move on. And we disassemble that robot and we build a bigger and stronger robot that can be used for competition, as seen by the one at the very end of the table. So, I'll pass it on to Jace.
So, coding is arguably the most important part of Vex Robotics, because without code, your robot doesn't know what to do and it doesn't go anywhere. and that's not good. So one of the problems, or one of the things that coding benefits is we can, if the right motor for some reason is better than the left motor, we can lower the power so that it drives straight and so that we can have a better chance of winning. And one of the biggest things that we do to improve our chances is encoders. And what those do is it basically allows the robot to stop when you need it to stop, go when you need it to go, and to stop from a certain distance of an object.
During the course of the year, we have many problems when we build our robots, and we might spend 3 to 4 hours on this problem trying to improve it. And this will help us in the future because in our job we will have many obstacles and we'll have to overcome them.
Competitions for Vex Robotics change every year. This is a photo of a competition last year, and you guys back there, I think you've got a big cube and one of the stars at your table. So those were some of the game elements that we had last year. And so the robots that the guys built last year were designed to work with those game elements. This year's game elements are different. We've got a couple on this front table. We have a mobile goal, the red piece, it's heavy, and a lot of yellow cones to stack. So this is a great aspect of Vex Robotics because you can't just continue with the same robot year after year. You have to re-engineer, you have to recode, and you have to strategize for that new game. So it gives students who take robotics, more than 1 year, which is fantastic, a new challenge for the year. The downside to that is that you have to buy new game elements every year. Vex does not reuse the same elements, just in a different way. They have you start over each year with brand new stuff. So that gets a little bit pricey. It's about $400 to $500 just to buy your game elements every year.
Okay, so you need teamwork and social skills because, for instance, during the competition, you'll be paired up with random people, and you need to talk and figure out what the strengths and weaknesses of each of the robots are, so you can figure out the best chance to win.
So qualifying for state and state matches, there are 3 ways to do this. One is by winning an excellence reward, which is for designing a good bot and having a good journal. There's another way, which is getting a good skill score. So at matches, they'll often run skill scores, and that's a minute of autonomous, I think, or a couple of seconds of autonomous and a couple of seconds of driver control to see just how good your bot is. And then finally, the last way to qualify for state is to win one of these matches. And so, notably, 96396D, our robot on the table that we took, it was the only one to qualify for state, and that was sheerly through the skill points. And so this is a video from one of the matchups. This one in the corner is the robot we have here at the table, 96396D. And so this is the autonomous, sorry, this is not autonomous, this is driver control. Ethan Houston here was our driver. And so as you can see, he's trying to move those cones out of the way because what he's trying to do is get the mobile goal into the 10-point zone. There, in the corner, you see the blue pipes. There are 3 zones. There's a 5-point zone as marked by the tape, a 10-point zone in between the smaller blue pipe and the thicker one, and then there is the 20-point zone, which is that small area there behind the big pipe. You get 2 points for stacking a cone onto any of the goals. There are 2 goal types, the mobile ones, like on the table, and then there are the stationary ones, which are the big tower ones. You get 2 points for parking, which means the different colored zones. There are 2 teams, the red team and the blue team, and for each color zone, you need to park there, and that gets you 2 points. So some of the points. You also get 5 points for tallest stack, which is why these bots, which were our opponents who beat us, are trying to stack as high as they can. That will get them 5 points for that stack right there. And yeah, of course, our partner is that little claw bot there. So it's kind of an easy way to tell why we lost.
Sorry guys, I lost my spot.
All right, now to put in perspective how costly a robotics program is, the starter kit for a robot costs $850, and that's just the starter kit. That will build you the simplest and easiest to code robot possible, and that alone costs $850 by itself. A full competition robot, like a fully built and like that one, for example, probably cost easily over $1,000 just for that robot. And right, so we mentioned the game elements earlier, and I guess the arena itself that we're playing in is also a part of the game elements, which we do not have all of them if you consider the wall. We need a wall because the wall is very important for like autonomous, because you need everything to be exactly where it was when you started. And yeah, that costs $800 by itself just for a metal and plexiglass wall around the arena. So that's our presentation. Thank you for coming out. Do you have any questions?
Please ask